Through James Webb Telescope, we saw more than we could ever dream of before. Through these simple images, we understood that when you look at the sky at night and see countless stars, the space between them that appears to be dark is not. If you have a lens as good as this one, you will see billions of galaxies no matter which direction you decide to look. The universe is much bigger than we have the capacity to imagine. That is the answer to the titular question of this video. Thank you for watching, click the subscribe button, like this video, and we'll meet you in the next video. But wait a minute, you might be thinking, it can't be that simple. And you would be 100% right. James Webb Space Telescope, or JWST for short, gave us a wider scope of the universe. We, as the only intelligent species in the whole universe, as far as we know, were looking at the world through a keyhole. Now, using the JWST, that keyhole was drilled quite a bit, and now we look at the universe from a hole that is the size of a golf ball. Let's take a look at one of the images from it to show you how that works in practice. This is a picture taken by the best telescope we had before JWST. Here is the question: what do you see? Since I can't hear your answer, I'll assume you said nothing, because there is nothing in this picture. It's a blank black picture. For all of history, up until the launch of JWST, whenever we looked at that part of space, we saw nothing. Therefore, we thought that there was nothing much in that slice of the universe. Now, using JWST and its massive horsepower, we looked at that part of the space once again, and this is what we saw. Quite a difference, wouldn't you say? These two images are different interpretations of the same black and white picture that was sent from JWST to Earth. This is a cluster of galaxies creatively named SMACS 0723. The fact that the name does not sound creative at all is the point. There are more galaxies in that one picture than there are grains of sand on Earth. You don't believe me? You probably shouldn't, because that's a made-up comparison, but the fact that it's at least a believable claim is what matters. So this picture is the result of that larger hole through which we look at the universe. We can look at more than things, and with that ability comes the responsibility to examine it. Now imagine that every dark part of this picture is also packed with galaxy clusters just like this one. Now stop imagining, because that is indeed the case. And if you are already asking how much of the universe can there be, then that means that you understand the absurdly unimaginable size of our playground. Making you drop your jaw through the floor is not the only mission the James Webb Space Telescope is assigned on its journey. There are at least two more crucial ones. The first is to use the data collected from JWST and use it to enhance our understanding of the universe. So far, we learned that we understand the universe even less than we initially thought. Case in point, the age of the universe. You might be familiar with this number. This is the most precise age of the universe that we could calculate so far. 13.8 billion years ago, the universe, by which we mean the space and matter, was condensed into a single point, a dot if you will. That dot, the point that encased all of our universe, is called the singularity. The Big Bang is the moment that the singularity started to expand at a rapidly accelerated speed. When we take the speed of the universe's expansion and reverse it, we get 13.8 billion years. That's an oversimplified way of explaining how we know the age of our universe. Here is the question. How long was a singularity a singularity? As in, how long was the universe in the singularity stage of its life? That's an obvious question that will come to your mind when you think about this explanation. Unfortunately, due to the specifics of singularity, we simply can't look far enough back to see how long the singularity existed. The JWST simply can't help us in that way. What it can help us with, however, is something much more intriguing. If we go back to the picture we saw earlier, we can take another good look at it and take any of those bright dots we like. As we said, all of them are galaxies. The thing is, those galaxies are way farther away than we thought we'd find any galaxies. On top of that, those galaxies are much smaller than we thought they would be if we thought we'd find any galaxies. Let's think about this differently. This dot in the middle of your screen is the epicenter of the Big Bang, the singularity. As the universe started expanding, matter and space started moving in all directions. We are somewhere in between the epicenter and the edge of the expanding universe. Those galaxies we saw in these pictures are far closer to the edge than we are. The farther the galaxy is from the epicenter, the older it is, which makes sense. They'd be the first ones to form as they started to go farther and farther away from the beginning. Well then, what's the problem, I hear you ask? The problem is that those galaxies are far smaller than they should be. The general theory was that the older the galaxy is, the bigger it is. We thought of galaxies as trees of massive proportions. If you let a tree grow, it will theoretically grow until it dies. That's how galaxies work. But if that was the case, then these smaller galaxies that are much older than ours can't be as small as they are. While this simple explanation is also an oversimplified version, at the very least, you should get the idea of the problems that the JWST caused with just that one image. The other problem James Webb Telescope showed us is that we don't even know how galaxies form. The working theory suggested that the first galaxies came together 450 million years after the Big Bang. But in these pictures, we can see galaxies that, if they are truly galaxies, must be assembled much closer to the Big Bang. Let's not get into that ordeal right now. And then there is the problem of a similar scale, but one of a different magnitude. That is the old star problem, and believe it or not, it has nothing to do with Hollywood. As any semi-decent astronomy book will tell you, a star's lifespan depends on its mass. Generally speaking, the bigger the mass, the faster it will consume all of its fuel. Think of a big star like a bonfire that was started, and all the wood was put in it. The bonfire will become hotter and hotter before it reaches the peak, and then that heat will make the fuel, in our case wood, burn up quicker than a normal small bonfire would use up its fuel due to less hot heat. The comparison is not that great, but again it's the principles that you need to get rather than the intricacies. That is to say that a small start will always outlast a megastar. What does this have to do with the JWST? Well, when we talked about old galaxies that should not exist, you'd imagine that those galaxies would have the oldest stars, right? Yes, exactly. Not only are those galaxies small, but many of the stars in them are of a smaller variety, and some of the smallest stars can live for somewhere between 12 and 20 billion years. If alarm bells are going off in your head, then that means you are paying attention. It will take a while before the scientists can do their magic and come up with the answers, but at the moment we can speculate. And one of the most interesting speculative inferences that we can make is the theory that some stars in these old galaxies are older than the galaxies themselves. That would mean that there can be stars almost as old as the Big Bang. What's the big problem with that? Well, for the first 200 million years after the Big Bang, stars did not exist. That is due to some part of the physics that is not necessary for you to understand right now. The bottom line is that those stars as we know them could not exist until after 200 or so million years after the beginning. If we can prove that even one of those small stars in one of those small galaxies is from the time within that 200 million year barrier, then that would require a large part of physics to be completely upgraded, because our current understanding of the universe cannot explain that seemingly little but frighteningly intriguing theory. All of these theories came from just one image, which was turned into two images because the light caught by the telescope is the kind of light that we can't see. Just one image and possibly world-changing consequences. That is what was truly seen through the JWST. But as we said in the beginning, this is just one side of the story. We can always get our minds blown by the stars that appear to be as old as the time elapsed since the start of the universe. But that is not as world-shattering as the direct evidence that extraterrestrial life exists somewhere in one of those distant old galaxies. The question is, can we see any evidence of aliens through the James Webb Telescope? That is the question for a different video. If you don't want to miss that video, you can subscribe to our channel and ring the bell icon. Otherwise, you can like this video, if you liked it, of course, no pressure. We will meet you in the next video, and until then, have a fulfilling day.